I have a big problem with people not respecting low voltage, and that's why most non-electrical workers are getting killed. We take for granted this 120-volt electrical power.
Welcome to the Portage County Safety Council podcast. We hope you enjoy today's featured message.
Wow, appreciate it. One of the things that got me into safety was accidents. But I am a family man. Now, I didn't have anything too close to home, but I have 12 children and 20 grandchildren. And I never, ever want any of my workers, and I've had over 100 electricians working for me at a time, and I never wanted to ever have to face their family because of something I didn't do in my safety program, okay? And enforcing the safety as well. And that wasn't easy in some of the countries I went to, because sometimes the safety culture is quite different and the value on human life is extremely low in some of the places I went. So it was really hard to convince people that I cared and that I was going to enforce the safety as well. And the worst thing I ever had to do, actually, was because a guy dropped dead of a heart attack. It wasn't an accident, but I had to call his wife in Australia and clean out his room and send his body home and all that. That was a miserable experience. Imagine how bad that would have been if it had been an accident on the job. It would have been worse. So safety is important. That applies beyond electrical, right? Most of my work for a good part of my career in heavy industry was with Alcoa. It's not far from here. Did headquarter in Pittsburgh, but they're not Steelers, they're aluminum, right? So I was in Saudi Arabia for 8 years. Recently came home at the end of June, and this is a video from Saudi Arabia. So I wanted to make sure you had something to see what we do in Saudi. Now, luckily, these guys are swinging on the low line that is the actual cable line, but you can tell they had done something up on the high voltage lines. And some Saudi people brought this into me because I was, in addition to be the engineering and maintenance, electrical engineering and maintenance manager for the facility, I also ran the electrical safety program. And I don't know if you heard them talking in Arabic. I said, how come you guys took this video? Well, we thought it was interesting. Why didn't you get out of your car and go stop those kids? What were you thinking, And, well, if Allah says it's time, hey. So it was really hard sometimes to get the safety behavior I wanted, when they have that attitude. But trying to get people to take action instead of just taking videos. I don't want anyone to be a hero trying to clear power or switches and things. I tell my electricians, if something goes wrong, run the other way. And then when you get far away, then take out your phone and take the video. All right? And don't try to save the day. Wait till the equipment takes care of itself. Eventually, it will clear. So I said I'd talk a little bit about the standards, just to give you an update. Like I said, 70B, a lot of people don't even know it exists. When people told me this, I couldn't believe it because when I trained those apprentices up in Northern New York back in the 90s, I used it as a textbook, just like the code book. By the way, the code book, the National Electrical Code Book, is probably the number one code or standard in the world. A lot of foreign countries that don't even base their standard on the NEC, they'll use the IEC 60364 standard, the international one. But to buy all the pieces of IEC 60364 will cost you over $5,000. They can buy the code book for $100, so their tech schools use our code book, okay? And it essentially meets all the same requirements. So it's the best thing in the world. And that's beyond electrical standards. That's all standards. It's the most famous and most used and most utilized. 70B, though, is the unknown one. And because 70 has been pushing 70E has been pushing the maintenance requirements for our workplace safety. People are saying, well, how do we meet those requirements? We always say, well, go to 70B. 70 what? Yeah, there's a maintenance standard for electrical, but it's called a recommended practice. So OSHA compliance officers generally steer clear of recommended practices, right? It's only recommended. So NFPA came to us and said, hey, committee members, how about we make it a code? Let's make it a real standard. And we said, okay, probably take a couple cycles to do that. Then they came to us and say, no, do it in the first cycle right now. So right now, the current version is 2019. The next one would be due is 2022. It's almost impossible to make all the changes that need to be made in that time frame. So it will probably be 2023 when we're done. Okay. The good news, though, it's really based on what's already in the recommended practice. So if companies start using the standard and developing their electrical maintenance, they'll be able to slide right into meeting the code when it comes out. So that's kind of what's happening in the standards world. 70E is always evolving a little bit, and 70 is always evolving. There's also a little move around in 70E has come out and said, hey, you have to make sure you inspect your installations properly. So when things are first installed, because we have a lot of places that have multi-skilled workers doing work, and we found a real drop in the quality of work for electrical work. There are not as many skilled workers out there as there used to be. So they're pushing for the quality of the work. So they're wanting to see good installation inspections, and it's got a taste of acceptance testing, where people aren't doing a lot to inspect the work. They just, Joe Cheapest contractor comes in, does some work, nothing's inspected, nothing's been tested, and then they turn it on and something's wrong. So we're seeing now in electrical safety fewer and fewer accidents. And we'd seen a drop in the last 25 years in the number of fatalities and in serious injuries in most areas of electrical safety. And where the big problem has been is now we're starting to see more accidents where nobody's even working on the gear. It just blows up when they're walking by it. Or they're working on the one over here, but the one behind them blows up. And people are getting hurt because it's just old and not maintained. So it's a concern. Now, I said this was going to be a practical application, so I'm going to talk a little more, too, about not just the standards. I mean, that's sort of a quick update of what's going on with the standards, but I want to talk, and I'll talk about this flavor here again. This is where we talk about the install being inspected, but I'll also talk about some practical safety, for you and at home. So we'll get into kind of like a little electrical safety presentation for the general person out there. Non-electrical people. So this was in 70E. This is where I was telling you we've made a change. This has been added where we have to have newly installed and modified systems have to be inspected to comply. You're going to see things more around acceptance testing requirements as well. That may go into the NEC. Maintenance in 2015, they actually added the requirement that your electrical safety program has to include elements of consider conditions of maintenance. They realized, we didn't really define conditions of maintenance, so in 2018, we've defined it. And the whole point is the whole electrical safety wheel has to be completed. It's taken many years. I mean, NFPA 70B came out in the 60s before 70E came out. And for years and years, people wanted us to put it in the National Electrical Code, but they said, no, that's just an installation standard. After you install it, it's up to, someone else to maintain it. Okay? So 70B came out in the 60s. It's been well ignored for many years, okay, but it's been out there and I did a survey of 700 electrical maintenance workers and supervisors and electricians and stuff. And in my survey of 700 people, only one person even knew 70B existed. I thought, that's sad. We got to get it out there. So then 70 says, hey, we're going to install it safely. 70E says we're going to work around it and on it safely. 70B says we're going to maintain it properly so it continues to be safe, almost like it was installed. And I also added 79 in here. That's the electrical machinery standard, industrial machinery. So it's kind of like another part or a more detailed part like 70, because we got to make sure we buy the proper equipment. Try to make sure it's not counterfeit equipment, that it's been designed to 79 standards. And by the way, there's an international standard for that too. IEC 60204 is almost the same as 79. There's just two chapters that have some differences. Okay, so even though 70 has a mirror copy in IEC, 70B does not. It's the only one in the world. I told you this one's the best in the world, but this is the only electrical maintenance standard in the world, a complete one. So could be good if we used it and followed it. Another significant change in 70E, maybe not that significant, but I liked it. You saw on the cover of their book, they made the hierarchy of controls right on the cover here. They just got it upside down. Okay, so I fixed it. This is really what it should look like, right? Because we all agree, right? PPE is the last thing we want to use. We've had this problem with people in 70E looking at it and say, oh, that's the PPE standard for electrical. That's where we get our arc flash clothing. It's not. I mean, yes, it does include that, but it's a work practice standard. It talks about much more than just what clothing we should be wearing for PPE or the PPE we should be using. And in it, and also in 70E, they've made a statement that you need to make elimination your highest priority. Now, I haven't seen OSHA actually cite anyone for this, but it seems to make sense to me that if a compliance officer walked into your facility and said, let me see your electrical safety program. Okay, here's our program. Okay, so show me evidence where you're doing elimination or substitution. Oh, we got great PPE, were you wearing the best flash hazard clothing, shields, gloves, good meters, Yeah, but where are you doing your substitution elimination? Why are we always depending on PPE? Well, that costs money when we're not making any major upgrades, so I can't do anything. Well, wait a minute. In your maintenance program, there's sometimes you're doing some replacements, you're doing some work. Don't you have a plan to improve as you go? If we're not doing we have to. We have to be getting up here in our pyramid, okay? This is the hierarchy of control for the risk. But that's actually a really good point. Arc flash studies, we talk about everyone has to have an arc flash study done, right? Well, a lot of people, I design new plants, mostly in the last 15 years, I've had clients that will design a new building, and they do it the same way they did the old buildings. There's many A&E firms that just crank out. Total installed cost is what wins them the bid. Total cost of ownership isn't part of it, okay? So it's very important what ends up happening. And I had a major university build a new residential facility. And they put in some panels in residence halls that have extremely high arc flash energies. Kids are walking by these panels every day. When they have something go wrong in their room and they have to have an electrician fix it, he can't work on it safely. Well, it's a bigger building, so we have to put in a bigger transformer. No, you could have used two smaller ones. You could have split the load. You could do other things in your design. Designing for safety is another issue. And so if you don't design with arc flash in mind, you'll miss the boat. You'll be down here trying to figure out how to deal with it instead of up here. In design, it has to be part of people's design standards. You have to specify, hey, I want to control arc flash. And I'm hoping that we'll get the National Electrical Code, we'll get some stuff in there about that for new installations in terms of the consideration for arc flash. We're working on it. By the way, it's not easy to change the code sometimes. Everyone like GFCIs? No. Okay, well, I'll get into the GFCIs later. But it was invented in 1961, and we didn't get it into the first one into the code until 1971. Sometimes we're slow to move on safety, right? Other changes, just real quick, there's more about job safety planning and briefing. We have to make sure our qualified electrical workers know how to plan their job, and they have to perform briefings before they work. Other changes or significant points, electrical safety program auditing. They talk about auditing every year. Qualified training, we have to make sure that the qualified electrical workers can demonstrate their skills. So a lot of people, how do you prove that your qualified electrical workers have demonstrated their skills? Do you have it documented? Every year you've documented that this guy's demonstrated his skills? Well, his supervisor kind of watches and he knows. Where's your documentation that this guy has demonstrated his skills? When we go into new clients, we do a demonstration of skills test because things have changed in electrical safety. And the things I learned when I was getting out of school in the 1980s were bad habits, okay? And when I first did my demonstration of skills test after I'd been working in safety for a while, I failed. And 90% of the people we test fail the first time if we don't do a lot of preparation ahead of time, a lot of coaching, because we have some bad habits. So got to be doing a demonstration of skill and getting these people to bring their skills to the new habits. For instance, just real quick, before I was born, which was a long, long time ago, high voltage workers always would test that their equipment was working, and they'd go check to make sure the power was off. Then they would go check their equipment that it's working again before they'd say, yep, we got the power off. Electric on low voltage, that's the way we were teaching it in the 60s. Okay? In fact, if it was low enough and you couldn't feel anything with your fingers, you could use your tongue. But too many electricians talking like this afterwards, so we stopped that. Okay? So now the standard says low voltage, you will test with your meter that it's working. Then you'll go verify zero voltage or absence of voltage. Then you go test your meter again, right? Because we've got to be sure. And I've watched electricians when they were doing their test, they happen to hit the button wrong or the whole button on their meter, and they don't get the voltage measurement. They think they got zero voltage, but their meter wasn't working. But they didn't go double check their meter. And I caught a guy and I said, whoa, stop. I don't think you actually have the power turned off. He said, yeah, I checked it with my meter. Well, I don't think your meter's working. Go check it on a known source, and it's not working. What did I do? I said, I think you hit the hold button. Sure enough. So it happens. And why would low voltage be any different than high voltage? Who here wants to be killed by high voltage? Oh, so you don't mind, it's okay to be killed by low voltage though, right? Oh, which voltage do you want to kill you? Oh, okay, good. We agree on that. So why wouldn't we do it the same way? It's lethal either way. Okay? I have a big problem with people not respecting low voltage, and that's why most non-electrical workers are getting killed. We take for granted this 120-volt electrical power. We'll get into that in a second, too. All right, so demonstrate the skills. We're going to do this on at least an annual basis. We actually test people, document it, and we give them pocket guides to help them make sure they get it right. But we document it like this. This is actually just the front sheet. It's it's 2 to 3 pages of things that we're checking so that we know that they're inspecting their PPE, they're inspecting their meters, they know what they need for a meter because they have to know how to select the meter properly. Most electricians that I've run into don't even know how to select the meter. They're using one that someone gave them, monkey see, monkey do, but they don't really know what goes into the meter and the standards to which it's built. And then they could go to Core or Fright and get a meter that they shouldn't be using in the workplace. You got to be careful not to use names, right? So the 120 volt is causing a lot of non-electrical workers to get electrocuted, all right? And usually it's associated with equipment grounding, not having the ground pin. So really quick, you've probably seen some of this stuff about the effects of AC current on the body, if you've been to any electrical safety training. And I want to put some of this in perspective. I'm going to give you the numbers, then I'll put it in perspective. 1 milliamp is when we start having this pain. Some of us, it's only a tingle. Most of us, it's pain. It hurts. Anyone in here ever get a shock? Okay, how many of you liked it? Yeah. Right, it hurt, right? How many want to hold their hand on there and go, yeah. Oh, you couldn't hold your hand on there? What happened? Because the AC current, it wasn't just that you felt pain and so you pulled away. The AC current caused your muscles to contract, and that was what pulled them away. Now, the only problem with that, usually that's what saved your life. Occasionally, when your muscles contract, that includes the fingers, and if you already have your hand on something round, it contracts around it, and you can't let go. We call that the no-let-go threshold. That happens at about 10 milliamps. And then we can go up to 30 milliamps and you can't breathe and scream. And we get up to 75 and we'll fibrillate your heart. So 7 milliamps, how much is that? Give you an idea. You go to plug into a wall socket, you're protected by a 20 amp breaker usually, sometimes 15, but usually a 20 amp breaker. This is a powerful weapon and we take it for granted. We got to stop taking it for granted. We got to employ some safety skills, using the proper equipment, inspecting our equipment properly, so that we're not getting people shocked and killed by this powerful weapon. You've got a shock before, but you're living on the lucky side. Let's not use all our luck on electrical safety. Let's use some skills, not get the shock, save our luck, and go buy a lottery ticket. Use that luck for the lottery ticket. All right? Here's the deal. That little ground pin there and the conductor that connects it, what's it do? Okay, your electrical engineers will tell you that the equipment grounding conductor has to be there so that it can safely conduct all of the fault current that could likely be imposed upon it from the source back and returning to the source so that it can clear the overcurrent protective device quickly. You got it memorized now?
Sure.
Now you know. How about this? You can teach that to your 7-year-old grandson, because I did. It prevents death. So we need to make sure we're not using cords that have missing ground pins. And by the way, I'm going to make a plug for a company, new company, about 4 years ago, out of Tennessee, American-made product, Solid Ground Cords, name of the company. And that's their website too, Solid Ground Cords. You'll notice on this, they have a solid pin that's designed in a certain way that does not break. The average extension cord on a construction site, the ground pin breaks within 2 months. And I've been on a lot of big construction sites. Right? And the cord end pulls out. Theirs do not pull out. They've been manufacturing these for almost 4 years. They have not a single reported ground pin break, and they have not have a single recorded pull out of their plug. Yes, they cost twice as much, I think, about twice as much, but they cost so much less when you start fixing cord ends. Okay? So I just make that quick plug. You can spend a lot of your time inspecting cords, right? I mean, guys show up at my house to do some work, and I'm usually repairing cords for the guy because I don't want him using his cord that has broken ground pin while he's working at my house, you know? And the electrocutions that occur most often are at 120 volts, not at high voltage and stuff, because they're happening around the home and also in the factory with non-electrical workers using tools and stuff. We need that pin and the wire connecting it to prevent electrocutions. The other thing that we have to prevent electrocutions is that ground fault circuit interrupter. So we want to make sure we're using GFCIs where we're supposed to do too. And just a real quick, so you know how they operate, and we'll clear up a few misconceptions. It compares the power from the hot wire going out to the return wire coming back. If those two, they're the same, whatever's going out is coming back, everything's cool. But if some power is going where it shouldn't, the GFCI is going to trip. So, how many people here, please be bold, think you need the ground pin for the GFCI to work? How many think you don't need it? Okay, so that's good. We have a pretty good. Now, episode 203 of CSI said you need the ground pin. But that's Hollywood science. Okay? In real science, you don't need the ground pin. If you thought you did, well, then you're a big CSI fan. Or there's a reason for it that's more than just Hollywood, okay? If you go to hit the test button and it doesn't trip, sometimes it won't necessarily trip when you have a missing ground pin, because that's what gives you the continuity back to the source. And the GFCI uses that to leak some current to test it. But the GFCI circuit itself doesn't care where it leaks to. It's just that test button uses the ground wire path. So the good thing about that, though, that means if you hit the test button and it doesn't work, something's still wrong, okay, because your ground is missing. But it could be that the GFCI stops working. And one thing I have noticed, when people put those GFCI receptacle types outside, we found about 50% of them fail in 6 to 12 months. They tend to breathe in some moisture and corrode the plungers and stop working. And unfortunately, they fail the wrong way. The power is stuck on. Okay, so the ground pin is still very, very important. It's your first level of defense. And don't forget, we have reaction hazards from shock too. It can cause us to fall off a ladder. And a GFCI shock, the 5 milliamps hurts. It hurts a lot. You're still going to fall off the ladder. The ground pin's your best bet. This is how it works. It's comparing the two. If something going through Andy Shockmore over here is more than up to 5 milliamps, it's going to trip and turn the power off. Same thing happens when it's the receptacle type or the portable type. The nice thing about this, I gave you those other levels before. The GFCI trip is right here. It still get the pain. You're still going to have the reaction hazard, but at least you'll be able to let go. And you'll be able to breathe, and you'll be able to continue letting your heart beat properly. Portable ones are great because we can test them before every use. That equipment grounding conductor, though, still is important, not just on our pins on our cords. On all of our equipment, everywhere, we have to have an equipment grounding conductor. We have a lot of old factories here that don't have equipment grounding conductors run with that old equipment because it was built so long ago. And, that means you don't have to update it, do you? Because it was built so long ago? The code back then didn't require it, right? And the code's not retroactive, is it? 1910-302B, OSHA Code of Federal Regulations, right? They do have retroactive parts in there. And they say grounding is one of those things that fit into that. You do have to update your grounding. So, 1991, one of the things that was getting me to be involved in safety up at Alcoa Cleveland Works, not far from here, we electrocuted a guy, electrician. Well, we fibrillated his heart. We defibrillated his heart, and he survived. They call it an electrocution once you go into fibrillation, though. Okay. He had unplugged something where someone had crossed some wires, and they had also had a fault someplace else way down the building, but they had no equipment grounding conductor. So the thing kept there running with this fault, and he ended up becoming part of that fault and opening up the circuit. Had 11 amps flow through him. He's lucky to be alive because they didn't update their equipment grounding when they were supposed to. So that was one of the accidents one of the early ones that I investigated with Alcoa, right after I investigated an arc flash incident where we killed someone. And he died 3 days after the arc flash. It took me another 7 years to get an arc flash standard in Alcoa. And FPA 70E was talking about arc flash long before industry accepted it, because it wasn't until the 2000 version that they actually came up with some tables that made it easy for OSHA to enforce. Before that, it was just talk, and they didn't know what to do. And 70E said, you got to do something. You got to take care of arc flash. Okay, how? No one knew how. So then in 2000 version, they finally gave them some solutions on how. Now, it's pretty well accepted. But equipment grounding is what's going to help us the most in electrical safety. Here's an example of a person who got burned and electrocuted. This is at the morgue on 120 volts. Here's a guy that was not an electrician. He was holding a tool. It was not grounded properly. It did not have a GFCI. It was a metal casing. It had a fault in the tool. He could not let go. And so it burned his hand. The next picture is worse. So if there's a problem because you just ate and stuff, you might want to know. This was right after it happened, right after they cleaned it at the hospital. This is a few days later. Internal burns are really nasty. All right, you usually lose limbs when you have a shock burn that does things inside your body. All right, well, just real quick, I just want to cover this thing because since I started talking about grounding and the ground pin and stuff, I just want to point out something about portable cord and plug related equipment. Now, if I bought you a tool for Christmas, or I give you this door prize, and I told you, hey, take this, and I want you to store it and handle it in a way that doesn't damage it. That'd be kind of a stupid thing to say, right? I mean, it's common sense. You're going to take care of it, right? You got a tool, you're going to take care of it. Isn't that common sense? Common sense isn't common, though, is it? So there's no such thing as common sense. So in the 70E committee, we said, hey, we're having accidents where people do this. And you guys know a lot of times we have someone in our company who isn't convinced about safety, all right? Who'll say, where's it say I got to do that? Just because it makes sense for safety doesn't mean he won't think or she thinks it makes sense because he doesn't want to spend the money or whatever. Where's it say I got to do that? So 70E, we put it in there. Oh, portable equipment shall be handled and stored in a manner that will not cause damage. That's where it says you got to do that. Hey, by the way, we don't want you to connect the equipment. You are using your cord to raise and lower the equipment up the ladder. Where's it say I got to do that? Can't do that. All right, right here, we put it in there. And don't fasten it with staples or hang it in a manner that's going to damage the cable. Where does it say I can't do that? Yeah, we put it in there. We're putting the common sense statements right in the standard now. Hey, now here's a good one. This is a really good one. Now I'll give you another step here. Grounding type equipment. If you have grounding type equipment, you got to have an equipment grounding conductor in it. Whoa, isn't that grounding type of equipment? Yeah, but you know what happens? Flexible cord used with grounding type utilization equipment shall contain an equipment grounding conductor. Well, by the way, 58% of the cords sold in Saudi Arabia do not. They come from China, mostly from China, from companies that just make these things and send them. And then there's always someone who says, why do I have to have that wire? It doesn't do anything. It prevents electrocutions, okay. But it doesn't do any real work. It doesn't cost much to electrocute a person from a poor country that's working in your country because their life's not worth much. If that's your attitude, why do you need an equipment grounding conductor? That costs a few cents. And by the way, when I get these products and I look at them, 2-year warranty, wow. I go look for the company, it doesn't exist. And we have a big problem now in this country with counterfeit product coming in as well. So you can get extension cords without an equipment grounding conductor, even though it has a prong on the end. So we have to write it into the standard. Whenever you buy a cord or anything, you got to test it before you use it because you never know what you're going to get. Test before use. Make sure it's wired properly. All the things are continuous. That means your attachment plugs and receptacles, everything you have, can't interrupt the continuity of the equipment ground. You can't use anything that interrupts the continuity. They shall not be used. That's those 3-prong to 2-prong adapters. Can't use them. I could go on all day, of course. I love electrical safety and stuff. But I want to give you a chance to ask a few questions. But I think that's a good lead-in for some good practical stuff. OSHA or the code essentially requires us to use listed equipment in our workplace. And OSHA's jurisdiction is the workplace. But you can go out and buy stuff that's not listed, so it's a little bit buyer beware. But don't forget, OSHA doesn't have jurisdiction on your home. And some of the companies, even some good brand names that sell certain things in the States, they'll sell cheaper stuff in other countries. And I've had a reputable company where I bought some equipment because it came with some stuff from China. And I was using it in Iceland. And when I went to get service for it, they said, no, we don't service that. I said, but it's your equipment. I said, well, we don't sell that in Europe. I said, why not? He says, it's not safe. But you sell it in China? Well, yeah, that's different. By the way, I think Michael did a thing on counterfeit products here before. And just as a tie-in, since I started talking about it a little bit, anytime you buy something, you're looking for that listing, Nationally Recognized Testing Lab, one of the OSHA-approved testing labs, UL, Factory Mutual, CSA, etc., TUV. But also, the Chinese know how to copy that too, or these counterfeiters know how to. I don't mean to pick on the Chinese. 87% of them come from China, but it's counterfeiters. Okay, it's a lot of good manufacturers and good people in China. They're people too. It's just that right now it's 87%, so they get a bad reputation. But the counterfeits usually will have a spelling mistake someplace on the label. So if you read everything on the label and indoor is spelled INDOUR, counterfeit, okay? Or, little things like that. You just got to read everything because they'll make a perfect UL stamp. UL came up with that hologram. They thought they were really good. It took them 2 weeks to copy that. So you got to look for those spelling mistakes and those other little things that are dead giveaways that it's a counterfeit. Anything else? Hey, thanks for having me. I appreciate it. I'll be up here for a while.
Thank you for listening. We hope you enjoyed today's podcast. For more episodes, check us out on iTunes, Spotify, Google Play, Podbean, or Stitcher. To get new episodes sent directly to your phone or smart device, be sure to subscribe. To learn more about how your company can earn up to a 4% Ohio BWC premium rebate by becoming an active member of the Portage County Safety Council, please visit our website at www.portagecountysafetycouncil.wordpress.com. The preceding information is for entertainment purposes only. Views expressed may not reflect the views of any affiliated or sponsoring individuals or organizations. Listeners should carefully weigh information provided and seek advice from an appropriate professional before implementing. Listener discretion is advised.